Hello everyone, so welcome back to the second part of the video. Now before starting, I'd like to make sure that you have understood the subnetting calculations in part 1. If you are still unclear, clear that first and only then watch this, otherwise you will be still confused about certain stuff here. Right, so in this part we're going to basically go through three methods of subnetting: the classful IP addressing, the fixed length variable subnet masking, and finally the variable length subnet masking. All right, so I'll just explain some stuff on the white screen first. So say there are two clients and one of them, say A, needs 120 hosts and B needs 3 hosts, right? So basically this guy needs 122 IP addresses and this guy needs 5 IP addresses, right? So this is the host and this is the IPs that I need to give. Also in the last lecture I said that you guys have to give them IPs in the power of 2. Others cannot be done. Other combinations is not possible because whenever you give a bit in the IP address, that's in power of 2. You cannot give a half bit away to network and half bit away to the host. Like you cannot have a subnet mask of 24.5. This value is discrete, right? So the first method, the class full IP addressing, here we know that there are three classes of IP addresses, right? So A, B, and C. So A has a host of 2 to the power 24 minus 2, B has 2 to the power 16 minus 2, and C class has 2 to the power 8 minus 2. So this is the smallest one and this is the largest one. So these are like three sets. Like you know how you get set menus in the restaurants and you always have to get the full package. You cannot get like half of that set menu. You always have to buy the full set no matter how little you eat, right? So there are these three set menus and this set C has the smallest number of items, which is 256. This has around 16k and I don't know, calculate that yourself, whatever that value is. It's huge, like in millions probably. Anyway, so these are the three sets you have available. Now host A needs, this host A needs only 120 IP addresses. Now among these three, to waste the minimum number of IP addresses, you have to choose 256, right? And then again, even for 3, you need just 3 IP hosts, but I mean you need 5 IPs, right? And even for this 5, even though you eat a little, just that one kebab possibly out of this whole set menu, you still need to buy this because this is the smallest there is in the classful IP addressing, right? All right, so going to the fixed length subnet masking now. So classful you have understood, that's the first one. Now the second one, the fixed length subnet masking. Here what you have to do is basically when you start breaking something, you have to break that in equal bursts. Now let's bring in our siblings. So say you can eat a double-decker burger in Chilox, like a huge burger, right? And then you have a smaller sibling who cannot eat as much. Like a normal small chicken burger from Chilox is more than enough. He or she cannot end that as well. But then there is mother. Your mother is going to be like, you are eating your double-decker Chilox burger, so your brother has to have that as well, like equality. All right. So say you have again 512. I'm sorry. Wait, I forgot to turn on the pen. Anyway, say you have 512 IP addresses. Now, once you start breaking it into 256, all the others must be 256. It cannot be this is wrong. Like one is 256, one is 182, and another one is 128. This is wrong, right? This is not possible. What you have to do is see, since one in the very beginning you have broken down into 256, the second one has to be 256 as well. And if you broke it into 128, it has to continue being 128. So you can have 4 128s here. And you get the idea. If I start breaking down into 64, all of them must be 64. Now in this example, as you can see, there are 3 networks, like this network, this network, this, and this is considered as a network as well. So this is known as the WAN network, and the other 3 is LAN. These 3 are all LAN, right? So this network has 3 LANs and 1 WAN. All right. So here, always when subnetting, we first have to see the requirements of the LANs or WANs. I mean the total networks that we need to configure. Now we need to configure both LAN and WAN. All right. So here we have, say, I'll just write it here. We have in Borani branch 15 hosts. Then in Motijil branch we have 30 hosts, and on Khulna we have 120 hosts. All right. So these are the hosts we have. This is the requirements. And WAN. For WAN, we need two hosts. Why two? Because in this WAN link, there are two IPs that we need to configure. So one for this interface and one for this interface. So these two add up to two hosts. So for each WAN, if in the question it mentions that there is 3 WAN links, so you need two hosts. All right, not 2 plus 2 plus 2. It's 3 separate twos. Right. So after this, what we need to do is we need to sort them in the descending order, like largest first and the smallest last. So out of this, 120 is the largest, so I'll write 120. Then the second largest is 30, then comes 15, and finally the smallest one is 2. Now when we see this series, you can identify that 120 is the largest one, right? And of course they asked for 120, but we have to give them 122 IP addresses. For 30 we need 32, for 15 we need 17, and for 2 we need 4, right? So among these 4, the largest is 120, and to satisfy 122 numbers, the smallest size that we can give them in the power of 2 is 128, right? So 2 to the power 6, so 2 to the power 2, 4, the 4, say 122, these are 122 burgers. You need 122 burgers for your party, right? So if you just buy 4 burgers, this won't satisfy 122 people. So you have then 8, no 16, no 32, no 64, 2 to the power 6, 64, still doesn't satisfy. Then 2 to the power 7, that's 128. And yes, 128 burgers will satisfy 122, the requirement of 122. There will be 6 extra burgers. That's a waste, but not exactly much. Now the problem with fixed length subnet masking is that once you have started to break into 128 groups, so you have to assign 128 to here, 128 to him, and 128 to the fourth one. No matter what the size is, the eldest brother got the largest burger, so all the siblings have to have the same size burgers, even if they can't eat that fully. Okay, so it's not that I'm sharing this single 128 with everyone. This is 4 separate 128 IP address blocks. So say you have 512, so I'll break that down into 4 128s. So I give the first one to this one, second one to this, third one to that one, and fourth one to this guy. All right, this is how fixed length subnet masking works. So I hope that cleared up the concept. Anyway, so all subnets on main network must have the same subnet mask, as I said. So since I was breaking them down into 2 to the power 7, I applied 7 bits to the host, so the rest of them are the network bits. So if this was a network, so 192.168.1.0/25 would have been the network address for all those subnets and whatnot. All right, so yeah, something like that. Anyway, so yeah, so this means that they all must have the same host, as I just said. So for example, how many networks do you need for the organization? So in this figure, we need 4, like 3 LANs and 1 WAN. How many network addresses do you have? I have only one network address, say one large one, 192.168.0.0/16. This is the large network I have. How many bits do you have for hosts? So in this case, I have 16 bits for hosts. And how many host bits do you need to borrow to create the number of subnetworks that you need? So I'll leave this to think for yourselves, like how many host bits do you need in total to create all these subnetworks here, right? So yeah, I'll create another supplement video if you need help here. Now there is another example of subnetting, like for example here they have this random networks like this one, this one, this one. These are LANs and there are two WANs, this one and this one. So see, gradually they have all the IP addresses assigned. So this was my main network, and then we subnetted everything to all the LANs. They did not assign any to the WANs, did they? 1 2 3 4 5 6 1 2 3. Oh, I did 30. I'm sorry. So they did assign to all the IP addresses. So yeah, right. So I hope that cleared up the fixed length subnet masking. If you need more examples, I'll be happy to create more examples. Okay. So next there is the VLSM. Now, fixed length subnet masking was the problem was that no matter how small the networks were, once I broke it, we couldn't have broken down it into smaller parts, right? So VLSM applies fixed length subnet fixed length subnet masking again and again to create variable length subnet masking. All right. So fixed length subnet masking was once, that was it, and here I can have like whatever I need. Like I can keep on breaking the subnets into smaller subnets to achieve what I need and to achieve smaller size networks. Okay, so here, as you can see, as I have said, like in the example, as you can see, like I need 200 hosts, and so I applied 256 because after 128 to the power 7 to the power 8 is 256, and for 200 I need 256. For 1000 I can apply 1024, which is 2 to the power 10, and then for 2 hosts I can assign just a block of size 2 IPs, like 2 to the power 1. All right, so this has no binding like the fixed length subnet masking. Like in fixed length subnet masking, in the same configuration, if it was in FLSM, it would be 1202, right? And because it's fixed length, I should have applied 1024 to this, 1024 to this, and 1024 to this as well. All right, so see the amount of loss, but in variables, let's subnet masking, if I need 2, I can have 2. Instead of this, I'll have 2. Instead of this, I have 256. So we save a lot of IP addresses. Now for comparison, I'll just show something here. So I have these two networks. Network A is of 120 hosts and network B is of 3 hosts. So naturally they would need 2 extra IPs each, so 122 IPs and 5 IPs. All right, so first the classful IP addressing. So I have a network of 122. Now, as I said, in classful IP addressing, we need the total of what do you say, the smallest we can have is 256, right? So we have 256. Now we bought this block of 256 and we need 122. So here we have a total waste of 134. Now network B, 5 hosts, and the smallest in classful IP addressing is class C, which is 256, and here we have a total waste of 251. So if I were to subnet using classful IP address and assign IP addresses to these two networks, we would have a waste of 385 IP addresses. That's a lot. In the fixed length subnet masking, we again have the same networks, but this is the largest one, right? The 122. So we have to have 128 IP addresses, which is 2 to the power 7, and hence we have a loss of only 6 IP addresses. And network B, it needs 5, and because in fixed length subnet masking, the subnet size must always be the same, so we have to give 128 here as well, since we gave 128 to the network A. And here we have a loss of 123 IP addresses and a total of 129. Now if you compare these two, see the waste came down from 385 to 129, but we are greedy, we want to like have even more even less waste, right? So then comes the variable and subnet masking. So fixed length subnet masking and variable subnet masking, they don't follow the classful IP addressing. They're just like classless IP addressing. So network A 122, and to satisfy 122 we need 128. So we're going to give them 128, and the waste is same as fixed length subnet masking, which is 6. And for network B, because it's variable length subnet masking, to satisfy 5 people, I need only 8, which is 2 to the power 3, right? So the waste now is only 3, and the waste came down to 9 only. See, so as you can see, the waste from came down all the way from 385 to only 9. So this is the minimum number we can reach with VLSM. There are going to be waste, so VLSM does not nullify wasting. It, I mean, minimizes the waste that it minimizes the IP waste, right? Anyway, so this is the solution of that, and now we're going to see the VLSM calculations in the next part. All right, so see ya.